there are a lot of continuous functions. The first example is polynomial functions. So suppose we have two functions f and g that are continuous at x equals a. And c is a constant. Then we can think of new functions by adding them up, by taking the difference, constant multiple, and product of two functions. Well, we want to say those new functions are again continuous at x equals a. The reason, here is a quick proof actually. By the limit laws, we know the limit of sum is sum of limits. Now that f and g are continuous at x equals a, the continuity gives you the limit f of a and then g of a. So this result exactly the value when you plug in a into this function. So that shows our new function f plus g is continuous again. And similar proof works for the second number 2. And for the number 3, well, limit law says that constant multiple gives you constant multiple of the limit. Again, continuity of f says that this limit is simply f of a. Again, this is the value that you will get when you plug in a into this function. So that means this function is continuous. Well, the proof for this number 4 is beyond our level, but it turns out that this new function is again continuous when two functions are continuous. Okay, so using this, we can prove polynomial functions are continuous. So look at this. We have some quadratic function. This function is continuous at every point x equals a. Because, look at this. Well, this function is made out of continuous functions. Well, what I'm saying is we can use those 4 operations to form this function f. So because f is made out of continuous functions, so for example, the first term, x squared, is product of two functions x. Of course, x is continuous. And second term is scalar multiple of continuous function. So 3 times continuous function. And this last term is again continuous. When you add them up, you will get new continuous function by this number 1 and number 2. So f is made out of continuous functions with operations above. So those operations, so you can use those 4 operations to create this function f. So this function is continuous. Actually, this is continuous at every point x equals a. So this explains every polynomial function is continuous at every x, or continuous on interval from negative infinity to infinity, or the set of all real numbers.